Greetings, AP Calculus students from Avon High School and other parts around the country or the world. If you're tuning in, you're more than welcome to take a look at this video dealing with, as you can see from the description here, antiderivatives. But we're going to move to example 4 in this particular video. And I wanted to sort of progress through the notes to kind of let anyone watching outside of Avon know what has led up to this particular problem that we're going to do. So we just recently discussed the whole idea of why we study antiderivatives and their connection to area under a curve. And then very, very quickly we sort of segued into actually how to, talking about how to find the antiderivative of various algebraic expressions using our basic 6 rules here. And we just progressed to slightly more complicated forms of antiderivatives. These are problems that I have already recorded in previous videos. And then we moved on into the integration of various trigonometric functions using our basic 6 formula here. And then I capped off with an example that was a brief introduction to what a slope field is and how to solve a very, very basic differential equation. And if you are currently taking Calculus AB and you're currently studying the topic of the antiderivative, you have yet to see a more robust unit over the differential equation, which is coming up probably in your class in the next few weeks. So as I said before, I wanted to move straight to example 4, where the directions say to solve the differential equation, knowing that f double prime of x is 3, f prime of 2 is 5, and f of 2 is 10. And one of the things that I want to make sure that we iron out very quickly is exactly what is a differential equation. And it's translated quite literally. A differential equation is indeed an equation that contains a derivative. And moreover, it is an equation that contains some independent variable. We're going to use x in this case. So for that particular definition, this guy here is going to serve as that differential equation. And take note that the differential equation can be of any order. It can be a first degree. It can be a second degree, like it is in this particular case. So in order to solve a differential equation, you basically have to undo any derivative that's attached to it. So if we see these two derivative pieces of notation, we need to undo the two derivatives. And the best way to undo a derivative is to take an antiderivative, or to integrate. And that's exactly what we're going to do, not just once, but twice. So our line of thought will be, if we were to take the antiderivative of f double prime of x, and we would do so with respect to x, that would indeed give us a single derivative, f prime of x. Now, specific to this particular problem, we're going to integrate 3 with respect to x. And according to our antidifferentiation rules, to take the integral here of 3, the antiderivative of 3, we just need to multiply it by the independent variable x, and then, of course, add some constant of integration. Now, not to try to confuse you on purpose here, but we're going to see a couple of different constants of integration throughout this problem, and I don't want it to even come across anyone's mind that these two constants might be the same value. So I'm going to use a subscript here of 1 for this constant. So we have our 3x plus c that's equivalent to our f prime. But the problem with this is if we continue to take the antiderivative, we're going to have a little bit of an issue with this c sub 1. And it turns out that we do have enough evidence here to find that particular c sub 1 value, knowing that f prime of 2 is 5. So we're going to use that particular piece of knowledge, use the fact that f prime of 2 is 5, and that simply means that this f prime value will take on the value of 5, and the x value in this expression will take on the value of 2, and then the only thing that's hanging around that looks like a variable is that C1, that constant C1 that we're of course going to be able to find. And in this instance, we're going to get C1 to be -1. So what does that all mean? Well, that means for us that this f prime of x that we just recently discovered has a particular solution, not just a general solution with a c in it, but a particular solution of 3x minus 1. That's going to enable us to continue on our merry way and find our f of x. And we will, of course, take the antiderivative of f prime of x, knowing that that will be our f of x. Now, specific to this problem, that's the antiderivative of 3x minus 1. All right, so maybe we have a slightly more complicated integral to figure out here, but when we antidifferentiate 3 times x, we would get 3, and then we would raise the power of the x up by 1 and divide by that same power. And then when we antidifferentiate 1, we would get -1 times x. And then, of course, we have another constant of integration, and this is where knowing to use those subscripts is really good mathematics. It kind of creates a little bit more formal atmosphere about the problem. And quite often what I would find students doing in this particular situation is if they did not know to use a subscript initially, as soon as they find that they're writing another constant, they can always go back and attach a 1 to these particular c's and then proceed with their new c value as having a subscript of 2. Now, it seems like we've got our final answer, our f of x, but knowing this value of c2 is still hanging around is a little bit problematic. So we can see that we have another clue up here, that f of 2 is equal to 10. So we're going to use that particular piece of knowledge, and we're going to find that c2 value. So f of x would be 10 whenever our x value is 2. And now we just have a simple algebra equation here to solve. 10 would be equivalent to, and then here we have 3 times 4, which is 12, divided by 2 is 6, of course. And then when we add, or combine, I should say, the 6 and the -2 to get 4, subtracting it over to the left side would tell us that C2 is going to be 6, which means we have our final answer. Our function f of x is going to be 3x squared over 2 minus x plus that constant that we just found. So pretty straightforward. These problems are fairly common. You'll see them both in a form that is sort of generic, like this particular problem, but we will also see them in a little bit more real-world application setting, which is going to be the focus of the next video, example 5, where we look at a motion of a thrown object straight up and down, and we apply the same kind of knowledge to that. So anyway, I hope this helps you out a little bit, and good luck, and I'll see you at the next video.